Hello, everyone. Welcome to today's webinar on accelerating the quality control process in metal additive manufacturing. My name is Guillaume Beau, and I will be your host for today's presentation. This webinar is part of our Ask an Expert series, which we started last year with great success. And in case you missed the previous webinars of the series, they are available on our website. So before we get started, here's a few housekeeping notes. So you can ask any question during the presentation using the question tab in your GoToWebinar control panel. We'll have a Q&A session at the end of the webinar to answer all of your questions. For those who are interested, there's also in the Hands-Out tab, still in your control panel, there's some brochure there for further reading. So all right, let's get started with the webinar. So, like I said, my name is Guillaume Beau, and I'm a product manager at Creoform. I spent the last 10 years working around 3D scanners and metrology. I started as an application engineer at Creoform 10 years ago. And then after 5 years, I moved to the product development, product managing still at Creoform. And I'll be joined today by my colleague, John Immonen. Hi, John.
Hello, Guillaume. Thank you for the introduction. Again, my name is John Immonen. Been associated to 3D scanning and 3D technology for inspection and reverse engineering for 28 some years now. My role here at Creoform is strategic account manager. I work with the account managers here locally in the US as well as abroad in other countries to ensure that our customers meet the objectives in a larger scale discussion. So I appreciate your time today and look forward to answering any questions you may have. Thank you.
So thank you, John. So between John and me, it's almost 40 years of experience in metrology, mostly John, as you can see, but still we'll try to share a little bit of that with you today. So as a starter, just to warm you up a little bit, I'd like to start with a question. So the question is, what type of measurement tool do you mainly use for your quality control? How so do you use traditional manual tools such as calipers, tapes, etc., traditional CMM, bridge type CMM, portable probing CMM such as measuring arms, laser trackers, optical CMM, a 3D scanner, or maybe you just don't have any measurement tools yet. So quick notes here for those watching from a smartphone, you'll have to scroll down and click on the submit button to register your answer. So I see it's still moving. Look at the results there. Still moving, giving you a few more seconds to answer the question. I think it's pretty stable there, so we're going to stop the question here. So 35% of you are still using manual measurement tools, which is great. It's great. Hopefully you'll learn about this presentation and how 3D scanners and optical CMM can help you tackle challenges that you can find in industries, and especially in the additive manufacturing industry. Still, a quarter of you are using scanners, so I think we'll show a couple of things here that will be good for you as well. So I'd like to start here with a little bit of history of the measurement tools and measurement in general. So the need for humans to measure things as old as civilizations. If we go back, it's almost when John started there, it's 3000 BC. Ancient Egyptians used their hands and feet to measure length and width. Since the length always varied from one person to the other, the royal cubit was then introduced, which was a granite rod that used the current king's dimension as the standard by which the measurements were done. And much later, the English did the same with their own kings, right? So in the 16th century, William Bedwell invented the ruler as we know it. Although historians have also found ivory and wood rulers that dated back to the ancient Egyptian, as we just seen. William Bedwell was still credited as the inventor of the ruler, as we know now. Then in 1795, the French revolutionary government introduces the metric system, which is now also known as the International System of Units. Of course, the meter definition has evolved over the centuries, but the meter is still considered today as the length reference to which every measurement tool refers. So from that point on in time, people had simple tools, the rulers, and a standard measurement system to refer to. But with the evolution of technology and product, people required more precise tools to do their measurements. Then in 1848, French inventor Jean Palmer receives a patent for the system Palmer, which is the first micrometer, still recognizable today with its U-shaped frame. And modern micrometers still use the same principle and basic design of a U-shaped frame, thimble, sleeve, spindle, anvil, and so on. So we have a more accurate tool to measure, but people, still needed more precise tools, but also tools capable of accurately measure more complex shapes, not only linear distances that you can measure with micrometer and rulers. So in the early 60s, we see the first coordinate measurement machines start to appear. It's made of a 3D tracing device with a simple digital readout, or DRO, displaying the XYZ position. So now we have an accurate measurement tools capable of measuring more complex of 3D measurements. So what would come next? In the 70s, portable CMM with the measuring arms that we can see revolutionized the measurement process. It was now possible to bring the metrology tool to the part rather than the part to the tools. And both the CMM and portable CMM are still used today. They evolved obviously from the first generations, but there are still technology that are widely used in the industries. But those technologies still have limits when it comes to measuring increasingly complex parts that comes with additive manufacturing processes. So what are those challenges? What are the challenges when it comes to measure those complex parts? So here I've listed what I consider the 5 main challenges that we see in today's industries. First, the shape. We live in an era where the design is really important. This is how companies distinguish themselves from the competition, by their design-oriented geometry and forms. And additive manufacturing also allows companies to reinvent themselves with design that are no longer constrained by traditional manufacturing techniques. Then there's the size. The part might be too large for the measurement equipment, or impossible to move around to bring to the CMM because either it's too heavy or it's fixed, so you cannot really move it. So all these could be also space restriction, where you don't have any space anyway to measure the part, so you try to measure it where it stands. Then there's the material. The part could be hard or soft, could be too hot to be touched, could be sticky. So there's different kind of material that you might try to measure here. There's the surface finish, as the part is dark or shiny, and then those parts could be tricky to measure for some technologies. And finally, there's obviously the time it takes to measure the parts. We all know that time is money, and the time required to measure those parts could increase exponentially with the complexity of the part. And then if you have to measure multiple parts, then you got a real problem on your hands, right? Because it just exponentially explode the time you need to do all those measurements. So here, another quick question. The question is, what would you consider to be your main challenge when measuring your parts? Is it the complexity of the shapes and the geometry you're trying to measure? Is it the size of your parts? the material, the surface finish, or is it the time it takes you to measure all the dimensions that you need? Again, for those watching from a smartphone, don't forget to scroll down and click on the submit button to register your answer. Let's keep moving. So we have 3 contender as the top answer. That's a little bit of everything. Okay. Oh, late answer here, but I think it's stopped moving. So we're gonna close the question. So if we look at the answer, so most of you consider the shape or geometry to be your main challenge. If it's related to the first answer you gave with the manual tools, it's really hard when you get complex shape to get the measurements you need. A couple of you have also answered size and time. So we'll cover all those challenges in the next couple slides. So how the latest technology of optical 3D CMMs and 3D scanners can help tackle those challenges. So first, the shape. So which is the most answered answer from the question. So here, obviously, 3D scanners are better suited for measuring non-geometrical shape. A traditional CMM would require the technician to program 1,000 of control points in order to get a good idea of all the shape of a part like this. And 3D scanners such as the Metroscan that we see in the video here can scan every details of the part in no time. As you can see, here's a loop, but it gives you a good idea of how many data you can get in a quite short amount of time. So with 3D scanner, it's now possible to characterize a complete part instead of sampling the surface with only a couple control points. And that it's compared to CMM. So if you compare to manual tools, there's no way you can measure those complex shapes with standard manual tools. Then there's the size. So systems like cruciform scanners can easily adapt to part size from 10 centimeters to 10 meters in size. They are fully portable, meaning that it's really easy to measure where the part is. As you can see here is a plane. Moving the plane to an area where your measuring tool is impossible. And the advantage here of cruciform technology when compared to its competition is that the scanners remain accurate in shop floor condition. So, in shop floor condition, you have vibrations, you have temperature changes, a lot of things going around. So cruciform technology will not lose accuracy because of those factors, thanks to its unique dynamic tracking. Then, for parts that are soft or hot, because they're just out of the manufacturing process, like here, obviously touch probing is not an option here. And again, 3D scanning is just the best solution, as it does not require you to touch the part to be able to measure it. So you can do measurement not just at the end of your manufacturing process, but you can jump in different steps and get measurement throughout the manufacturing process. Then the surface finish. Obviously, the surface finish is not a problem for touch probing devices, but it could be for some 3D scanners. Dark surfaces absorb the light, and shiny surfaces reflect it, so making it hard for some scanner to capture the surface. So at this point, selecting a scanner capable of tackling those challenging surfaces is important, as you don't want to spend additional time prepping the part by mattifying the surface with a powder or painting it. And scanner, like we see here on the video, like it's the Metroscan again, it can tackle about any type of surfaces without needing to prepare the part. So again, you'll save time at the end. Speaking of time, like I said, the more complex the part is, the longer it'll take you to measure it, especially with a CMM where you need to program all those features. But with a scanner, you know, like the MetroScan again, you can get your measurement done in no time. You can see here my colleague Matthew scanning like quite a small panel, but you know, 16 seconds, so it's not too too shabby here. The scanner takes 1.8 million points per second. So you know, now it's possible to scan large parts, complex parts, in a fraction of the time it would take you to do those measurements with a CMM or a measuring arm. So that was quickly to overview all those challenges. Now we'll have a look at a short video presenting a company that made the switch to an optical CMM and 3D laser scanners to tackle their own measurement challenges. Just be careful here, as the video may pop up in another window. You can quickly access it by clicking on the GoToWebinar icon in your taskbar if you cannot find the video. So I'm gonna start the video now. Enjoy.
First of all, it's super cool. This doesn't have to be part of it, but I think it's so cool. I love teaching people how to use the scanner and seeing the look on their face the first time they see the scan being created in the software while you're capturing it.
Lincoln Electric Additive Solutions is a full-service provider of large metal parts using Lincoln's in-house additive technology. The fact that we are going to make very large parts, measuring feet and meters, hundreds, sometimes thousands of pounds, we knew that a coordinate measurement machine was not going to cut it. So we looked at alternatives, and 3D scanning fit the bill.
We chose 3D scanning opposed to conventional measurement techniques because it allows us to get a full 3D surface model of what we just printed, and then we can take that and compare it back to the original CAD model.
A lot of times we have parts with unique features. We want to make sure those features are exactly where they need to be. So we need the 3D scans to encompass all of the complex features that we're printing and also make sure that we can verify all of those features are correct.
There are a number of benefits the Creaform MetroScan 3D provides to us. First of all, it is very fast, so we can measure our parts in a matter of minutes. Secondly, it allows us to take the measurement tool to the parts rather than the parts to the tool. Our parts are very heavy and large, so minimizing the movement of the parts is important to us.
What makes the MetroScan great is that it's a non-contact solution. We're able to scan our parts and verify dimensional quality anytime during the manufacturing process, even mid-print when the part is still too hot to touch.
The MetroScan helps our business because we can have confidence that every part that goes out the door is according to customer specifications. Also, it helps us in speed to market because it is such a fast way of measuring parts. Lincoln Electric Additive Solutions is growing, and as we expand, Creaform's MetroScan will continue to be an integral part of our manufacturing process.
Thank you, Guillaume, for the introduction on the Lincoln Electric project. Some of you may need to also touch the button down a little bit lower again to get the screen back. Hopefully it'll flip back for you. But I just want to take a moment and discuss the Lincoln Electric project. Lincoln Electric does some things pretty unique with the additive manufacturing as it's addressed to the metal additive manufacturing. The Lincoln Electric takes your standard products such as welding devices, and they basically put it on a positioning device, and they build up the material with the additive material. Lincoln Electric has selected the Creaform product to be well suited for their application as rather large parts here. Setting these parts on a conventional CMM may take a little bit of time, and also maybe add a little bit of danger there as well. What you'll see in the images here, that again, very large parts, very heavy parts, and with the Creaform MetroScan in this case, the information could be collected in a very efficient and quick manner. It will provide a very comprehensive report as well to be able to support the customer's needs. This ensures that the product that Lincoln Electric is going to ship out from their facilities to their customers are in fact meet their dimensional requirements. Very important. Something also to note here is you can also take the scanner inside the machine as a setup feature, as they want to set up. Maybe they have a potential issue with maybe a little bit of shift. They can do corrective actions and get it back into a proper process. You'll hear him saying it several times throughout this video is about the speed of the device. So we feel we're one of the quickest for sure in speed and the data acquisition as well as accuracy. The accuracy associated to this system, it meets and very much so exceeds the requirements for the dimensional control aspects. Moving forward, take a moment here and go if you just trying to advance slide here. Sorry about that. I want to take a moment here and maybe do a reintroduction again. My name is John Immonen, Strategic Account Manager for Creaform. I support the North American market for the larger customer base as well as international base. I have teammates that I work with very closely across the international markets. What we do is we try to bring some ideas and what we can do to better enhance the customer's needs and how their throughput and help them achieve their attainable goals. I was originally introduced into the 3D scanning technologies back in the early 90s, 1992, 91, 92 was the first time I was privy to a portable CMM for that matter, as well as conventional CMMs, to be able to collect information in a format. In 96, 97, the 3D scanning came into play. Very interesting technology. But what we've seen with that type of technology, it was primarily privy to or supported the reverse engineering industry. What we see today, historically, is in the 90s and early 2000s, 3D scanning supported the reverse engineering applications. So probably 90% of the market was, in that time, was probably reverse engineering. 10% of that market was, in fact, inspection. The adoption of inspection to the 3D scanning took a little bit to gain traction, as accuracies and reliability came into play. It indeed became a very formidable tool to be able to inspect parts as well. Today, what we see the inverse, what I would call the inverse of that, you'd see 90% of what we touch today is in fact inspection, and 10% of that would be reverse engineering, but it still is a major part of our industry. Also, back in the late 90s, I was privy to some of the first 3D printing machines. I thought it was just incredible technology back then. It was amazing that you could actually take something and process something with a 3D data set and actually make a live part from basically a vat of liquid in that point. From that point forward, I've been closely associated to the 3D scanning technologies as from reverse engineering as well as inspection, how 3D scanning is related to that market. What I'd like to do is talk about a couple more projects here. One of the projects that I follow kind of closely is the American Magic. American Magic is a premier yacht racing club, or sailboat racing, very high technology, very high demands in this particular market. The American Magic is a team supported by the New York Yacht Club. And what we'll see from this particular application is a very fast-paced time to market, if you would. But it's all held within their confines of what they would like to market. But what you'll see is how they utilize the system, in fact, for 3D printing, as well as the 3D modeling, as well as 3D inspection, more so to see if the parts that they have received, either A, received, or B, that they have made, are in fact within tolerance and want to go to fit it to the craft. Pushing forward on that, you'll see that these crafts are some pretty amazing devices. As technology advances, these things are actually literally flying now with the hydrofoil technology. I find that to be truly amazing, and be able to support this in a context of what they feel is necessary. Some of the key attributes of the Creaform scanner and how they utilize it at the American Magic. American Magic, again, the the funds can be pretty deep for this. So one of the things that they've mentioned, and one of the benefits of the Creaform scanner is they say a team can generate more capital or get more money. They can always get more money, but what they can't do is they can't get more time. This time is very time sensitive in this particular process. So what the Creaform scanner has allowed them to do is to take information, collect information, digitally model it, what I like to call as well as digitally twinning. So we have a digital twin of this model, so they can actually do analysis on it, they can do inspections on it, and they can also reverse engineer with these particular processes. So, you know, again, not necessarily buying them any time, or in fact does buy them time as opposed to offering more money. With the scanner, again, they can collect the information. In this case, they're using a Creaform HandyScan. HandyScan is a very portable device. So what this allows them to do is get into some very small areas or very confined areas in some cases, and they can collect the information in a very streamlined format. Once they collect the information, they can either do a couple things with it. Again, inspection primarily, reverse engineering, or maybe just an A to B comparison, something real. But without 3D scanning, you basically have to take some measurements and maybe some, I wouldn't say uneducated guesses, but they can take some very concise information and be able to move forward with this information. This foregoes a lot of the processes, what they do with guessing, and what it offers is a lot more time of the craft or the boat being in the water and actually doing physical testing. Some of the processes they do, you'll see that they scan, you know, little minute features or look some very key features. And in this case, they've measured a very small part, and they want to be able to see if it fits inside the cavity and what they intend. So they actually take some measurements, and they'll be able to process this information from a 3D printed part. Does it meet the specifications of what they put forth? And will it fit inside the cavity, or will it mate properly to the cavity into which it's intended? It's a quick video here. You'll see that's a nice video with the craft in the background, and again, rather amazing technology. Just to say, you know, carbon fiber and a lot of you know, very unique processes here. Again, this is you know, been released since the boat went in the water, but they're working on hopefully a new one here. So some of the processes with the American Magic Cup, or the cup for the cup race, they contended for the 36th annual America's Cup. Unfortunately, they had a mishap in the race, and the boat did unfortunately capsize, and they weren't able to complete the race. But they have made a statement in the 37th annual America's Cup. They will make another challenge going forward. So we're looking forward to that. Hopefully, you'll follow them as well. Switching gears a little bit here, we're going to talk a little bit differently about one of our customers. This switches gears a bit to, again, composites, so very, very near and dear, but they also utilize printing as well. So ATC, or Advanced Thermal Composites, or Thermoplastic Composites, is a company out west. It supports the 3D scanning. What the ATC's process is, or what their product is they make aerospace structural components from high-end composites, thermoplastic composites, as well as some 3D printing applications as well. So they use the 3D printer in some unique cases. They use a 3D printing and to actually establish the fixtures or some of the fixturing of their particular products, as well as some of the shippable parts. ATC ships as many as 800,000 parts per year for the aerospace industry. This has been a very received process inside internally. So we'll talk a little bit about their quality control aspects. The quality control aspects, they've utilized a Metroscan 750 in this case, and they've scanned pretty much 100% of the parts that come through the door. The processing that they've aligned themselves to do is traditionally they were measuring a lot of their parts with a conventional CMM. The conventional CMM is what they identified was a bottleneck in their process. It was taking up to 3 to 4 hours to measure any one part prior to its shipment, and they considered it to be a bottleneck. they were privy to the 3D scanning technologies, and they chose the Creaform MetraScan in this case to be able to process the information. And I have a quote from them. A number that they quoted to us was on a conventional CMM, it took them up to 3 hours, a minimum of 3 hours to measure a part and process the information and generate a report. Whereas the Creaform MetraScan allows them to measure a part within 20 minutes and have a fully capable part and a fully processed export of a report. That report is again held within their confines, and they'll be able to complete the information and be able to ensure that their customers are receiving a proper quality part. Some of the photos here, you can see they're actually physically measuring the part, but they've also used 3D printing to build the fixtures really quick and be able to process this information in a very streamlined manner. With ATC's function of what they support here, again, it's something that they do very quick to market, and with the scanner, they can afford to be able to scan more parts to be able to ship out to the customers in a more streamlined fashion. Again, this is a couple of fixtures that they've generated as well, and they quantify them with the MetraScan and be able to ensure that their quality objectives are in fact met. So we've covered a lot of information about 3D scanning and 3D scanning inspection and how it's supporting the inspection realm, and also what the transition to that market may have supported as well. So as we move forward, I'm going to bring it a little more personal. Something I did, I had a scanner in my desk, and I had a problem to solve. Turned into a problem-solving device. Kicking and screaming as came into the 21st century, adopted a Ring doorbell to my home. In front of my home, I have a stone facade, if you will, and then there was also a brick mold as well. So I didn't have any place to mount this doorbell, so I was like, I'll 3D scan it and 3D print the part out and process this part to be able to support the doorbell. And sure enough, what I did is I took the 3D scanner, generated a 3D contoured surface with Creaform's VX model, made a very nice, quick, and concise and accurate 3D model representation of the rock facade. Very unique shape, nothing else like it, of course. And I took that information and further made did some Boolean extractions inside SolidWorks, removed the solids, removed the features, did some basic profile and extrusions, did some Boolean removal. And finally, I removed the 3D surface from the Boolean 3D part, added a couple of features for mounting, and generated a 3D solid of that particular mount. And then once I had a 3D solid, of course, I took it and 3D printed it. And today, this system, the doorbell still lives. And I want to say that I did this 4 or 5 years ago, so it's still holding out perfectly. And so I just want to take a quick snapshot. We always get into this narrow discussion about how we did this and that. I just wanted to take a little more personal as well and see what we can do to offer it. But I appreciate your time and look forward to any questions you may have. Please keep those questions coming in. Looks like quite a few coming in as we speak, and I'll be happy to come back a little bit here and answer questions. But right now I'm going to hand it over to Guillaume and let him take it away from here. Thank you very much.
Thank you, John. Very interesting, both the customers, but also your little project there. So those are good examples on how companies, John, have adopted 3D scanning to help them with their manufacturing or the little problems. Creaform was founded because other measurement technologies, even if they were great in metrology lab, they were simply not suitable for, let's say, shop floor environment. So moving to the part to scan big parts, and Creaform made its mission to help companies solving those challenging parts measurement and push their boundaries into the measurement realm. A little bit of information about Creaform. So here's a quick overview of our metrology lineup. So we have on top, you have the Black series laser scanners with the MetroScan Black on the left, which is aimed at larger part size with minimal targeting, and the HandyScan Black, which is aimed at the small to medium part size and confined space as well. We also have photogrammetry and touch probing options with the MaxShot Next and HandyProbe Next. And finally, we have the R series scanners with the MetroScan R Black, which is the robot mounted version of the MetroScan Black that we've seen in a couple of the videos. And also the Cube R, which is a complete turnkey measurement cell. But what you've just seen here is more of our metrology lineup. We have other scanners for different type of applications. So, for more information, just check our website, creaform3d.com. A little bit of on the footprint of Creaform. Creaform is a Canadian-based company with headquarters in Lévis, Quebec. So this is where the R&D and the production is. So everything's made in Quebec. But we also have 15 offices in 12 different countries to meet the demand of our global customers with local service, language skills, and spare inventory and so on. So everything we need to be able to support our customers worldwide. Just to wrap things up here, here's a few takeaways, and for that I'll go back over the 5 main challenges of complex part measurements. The number one is the shape. 3D scanners are very versatile, giving the ability to measure almost anything. Also, Creaform products are easy to transport anywhere on the shop floor, or if you need to travel to a plant on the other side of the country, so you'll be able to measure everything everywhere. We've also seen that 3D scanners are the best tool to measure different types of material, especially when you cannot touch the part or manipulate the part. 3D scanning is the solution. And also, in 3D scanning, Creaform product can tackle any surface finish, from chrome-like surfaces to dark black surfaces. We can scan them all without the need to powder or prepare the part. And finally, as we've seen in the videos again, Creaform 3D scanners are really, really fast, making the whole process quicker and reducing the production downtime, which at the end just saves money. So basically, optical CMM and Creaform 3D scanners were designed with those complex part challenges in mind. And with the Industry 4.0 and smart factories, a company will tend to get closer and closer to their manufacturing processes. And this is where we think that 3D scanners and optical CMM will be the perfect tool to have them achieve that next step. So that would be it for our presentation. I hope you liked it. Now we'll move on to the Q&A session. There were already some questions that came in during the presentation, but you can still ask your questions in the question tab in the Go to Webinar control panel. We'll do our best to answer all of your questions, and we'll follow up with you if necessary. So let's get started with some of the questions that we received during the presentation. What are the surface limit of the HandyScan and MetroScan? Example, a C-bar with the height of 0.03. John, you have an answer for that?
Yeah, so I guess 0.03 inches or 0.3 millimeters. So I'm gonna I'm gonna select it. I'm gonna select probably the millimeters in this case. 0.3
inch.
It is
got the right feedback from Shane left the question.
So yeah, 30 thou, of course, it's under a millimeter, so we can definitely see that. And it depends on really the geometry surrounding that particular counterbore. A little tighter to measure, but by all means, we could put it in single line mode and be able to very intricately be able to select this information out. So the answer is you're getting a little bit on the limits, to be honest, but looks like this would be certainly attainable. again, we like to try it, I guess, is really, the proof's in the pudding. Let us try it for you.
Good. Another question here, again by Jay. When it comes to reflective surfaces, what are the limits of the Elite series? 16 to chrome level reflectivity. So have you tested those?
I'll be happy to answer a little bit too. I'm not sure about the 16 to chrome. We have processed the blue light technology in the HandyScan and the MetroScan process, and upon the release of that, we scan actually chrome parts. So chrome is certainly an objective that we can measure with either the systems in a very stream format. The answer is yes, we can do chrome. I'm going to assume that 16 is a little bit light, a rougher finish, but a chrome level for sure. We've done polished tools, we've done fully polished elements, and done really well on it. Where we do get into a little information, if let's say a mirror has a surface over top of it where it's glass, that's where we may have a little bit of problem measuring it, because it's actually a glass feature with a film on the back side of it, and we have a harder time. But if it is actually on the polished material is actually on the side, processed on the material with zero offset thickness of any film on top of it, the answer is yes, we can certainly measure that.
Perfect. Thanks, John. Another question here is the scanner are certified? I'll take that one. Yes, depending on which scanner we're talking about. So both the HandyScan Black and MetroScan Black are certified. There are 17025. They are calibrated in a certified lab 17025 against the VDI VD 2634 Part 3 standard. So everything you need for your quality management team to be happy with. Obviously, we have other scanners that don't require those kind of certifications, but the scanners that we aim to the metrology market, they are fully certified with the utmost standards. Here I have a question. I'm not sure. After data collection, you have a demo of geometry conforming process? Question mark. Validation process. Not sure about this question, John. Do you?
Can you read it once again, please?
After data collection, you have a demo of geometry conforming process? Question mark. Validation process. So, not sure.
Try to answer.
Danny, about the question. I can explain what you get out of the scanner. Maybe that answered the question, maybe not, but it's good information anyway. So when you scan with ClearForm Scanner, you have a mesh. The direct input is a mesh. It's not the point cloud that you need to process. It's a mesh. It's as soon as you scan, it's a mesh that shows in on the computer screen live as you scan, so you can see how much you scan. And when you finalize that, we have a couple algorithms tweaking a couple of things, but quickly you have a mesh that you can work with. And depending on what you want to do with it, you just go in a reverse engineering software or inspection software when you can get your measurement or extract your features for reverse engineering.
Yeah, I think I'll add a little bit to that. I think just thinking through the questionnaire, what I can ascertain from that, maybe the process would be, can we extrapolate geometrical features? And the answer is yes, we could extrapolate that if those features in the software in a downstream process. So some of the softwares that we do support is of course the VX Element software that Creaform supports, as well as any third-party softwares that might be available. Third-party software such as Polyworks. Polyworks is a great tool. Any of the Geomagic products, the inspection and reverse engineering tools, those will also create process and geometric. Metrolog, any of the big players that are not necessarily bound to any one company, any of the third-party applications, we certainly connect to them. So our list is pretty comprehensive of what we can connect to as well.
Good. Thank you again. we have another question from Jay. What are the tolerances and dimensional limits of the Elite Black? We have tolerances of down to 1 tau, plus minus 1 tau, and true position of plus minus 5 taus. John, you want to take that one? Or
You got it?
okay, I'll go. For sure. Both the Metroscan and HandyScan Black Elites have a tolerance of 25 microns. It's a local accuracy. I work in the metric system, but that's around a tau, I think. That's the local accuracy. So that would be the equivalent of a feature you try to measure. In the standards, it's a sphere, but could be a hole that you measure. You have a 1 tau tolerance, and then if you're trying to measure something, what we call the volumetric accuracy, it's with the Metroscan Black, it's 3 taus or 78 microns in the volume, but that's pretty big volume, 16.6 cubic meter, and so if you do linear distances inside that volume, you'll get an accuracy of around 78 microns or 3 tau. For the HandyScan, do we really need to use the targets or the stickers? Yes, the HandyScan is the positioning of the HandyScan is made through those targets that you've seen in a couple of the images there. If you don't want or can't apply those stickers, there's different things depending on the size of the parts. The stickers need to be seen by the scanner, but it's not necessarily to put them on the part. If you have a small parts, you can place the stickers on the table around, and you'll be able to scan the part. But if it's a bigger part, you'll have to put stickers. But for those cases, we have the Metroscan where targeting is not necessary. You can put a couple of targets to track vibrations and everything, but again, they don't need to be on the part at all. It could be on your jig or on the table. But if you don't want, your environment is stable enough, you don't want to use targets, it's totally possible with the Metroscan as well. So really different technologies for different needs and application. So that's all the time we had. So thank you again for the great questions. We need to make a cut here. For those who had questions that didn't get answered, be assured that we'll be happy to reach out and follow up on that. In case you arrived late and or had technical issues, the webinar is being recorded and will be available on our website shortly. You will receive a link in the upcoming days. We also added a brochure in the handout tab for those interested. Also, we have 2 questions that will pop up when you leave the webinar. If you could make sure to answer them, that would be much appreciated. Again, thank you, John, and thank you all for attending our webinar today. You have been a great audience. Thank you again, and have a great day.
Thank you for your time.